Hi guys. Okay, quadratics. This means nothing to you. I understand that. You guys look at this and you're like, what? We're going to talk about all sorts of different polynomials in the next couple days. Third power, fourth power, fifth power, sixth power. But all this is really telling you is that there's polynomial functions of the x degree and n. N is the exponent that we're looking at. We'll say to the nth degree. So if I have like 3x squared plus 4x minus 1, this is to the second degree. Whatever the highest exponent is when you're in your problem. So if you have like 3x to the fifth minus 6x plus 1, this would be to the fifth degree. Everybody understand that? Just the highest exponent. We talked about that.
Yep.
And we're going to talk about n as the exponent later on. But today we're talking about a quadratic function. Okay, a quadratic function is squared. You guys have seen that a million times. This is what we're going to refer to as standard form. Or ax squared plus bx plus c, where the number in front of x squared is your a term, the number in front of x is your b, and then your constant is c. And that'll be helpful. You guys have seen this a million times. What is this formula that you have seen?
The quadratic formula.
The quadratic formula. We will be using that. Maybe not much today, but the next few weeks we will be. And those letters represent numbers that are in your quadratic function when it's in standard form. Okay, well, you can tell a lot about a parabola by the equation itself and by finding the vertex. But all this is just telling us is that the shape of a quadratic is a parabola. It's a U. It'll either be going upwards or downwards. What's the difference between the upward and the downward parabola?
The negative?
Yep. Which one's negative?
The one going downward.
Yep. Because it's sad, right? A positive parabola is smiling. A negative parabola looks sad. I know I say some ridiculous things, but you guys always remember them, so that's what's important. When we talk about different parabolas, we're going to talk about the direction that they open, their axis of symmetry, their vertex, that sort of thing. If I drew for you, again, remember I'm the best artist in the world, so this is the most perfect parabola you've ever seen. All right, just by looking at this, I'm going to ask you guys some things, and you can tell me a bunch of stuff. First of all, is this parabola, is this equation positive or negative?
It's positive.
How do you know?
Because it's smiling.
Because
Like you
it's
said,
smiling,
it goes
it's
up.
happy. There you go, good. Thank you, David. Does anybody know what this point right here is called?
Vertex.
That's your vertex, all right? That's going to be your X and Y. There's also a line that goes right through here. And it cuts your parabola in half. It's a vertical line that cuts your parabola in half. Does anybody know what that's called?
Axis of symmetry.
The axis of symmetry, good. The axis of symmetry is just the x part of your vertex. A lot of times you'll see it called the AOS, axis of symmetry. Is this, guys, what I point to here, is this a minimum point or a maximum point? Think about what the word minimum means versus maximum. Minimum is the lowest, maximum is the highest. So is that the lowest point on the graph or is it the highest point on the graph?
Lowest.
That is the lowest. That would be a minimum. But at this point, you would read minimum and maximum, and that's the y part of the vertex. So your axis of symmetry, your AOS, that vertical line that cuts the parabola in half, is the x part of the vertex. I'll do it in green. And then the maximum or minimum is the y part of the vertex. So once you find the vertex, you can really tell a lot of stuff. Write this down, and if any of you ever get this question wrong on a test or a quiz, I'm going to be so upset at you. The domain for every single parabola we talk about from now until you are 923 years old is negative infinity to positive infinity. You have arrows at both ends, and they're always going in the same direction, so it's forever getting wider, whether it's negative or positive. And you're only going to have two choices for range. Range is either going to be negative infinity to the y part of the vertex, or the y part of the vertex.
Could you be louder? I'm trying to learn math.
I'm sorry, I'll be quiet. Isabel, I know you're not talking to me. You have two choices.
Oh my gosh. Oh my gosh. I was so...
You're fine.
That was my brother that came in.
You're fine. Don't worry about it. You're fine. You have two choices for range, guys. It's either going to be these two cases. It's either going to be negative infinity to the y part of the vertex. That's what happens when your parabola is negative. Or it's going to be the y part of the vertex to infinity. So it just depends on the direction that your parabola is going. But you can tell all of these things just by looking at the vertex and the direction that the parabola goes. I know this is a review. I know. Everyone saw this in Algebra 2. You may not remember it all, but I know you guys all saw it. When I talk about intercepts, well, I'll talk about that in a second. I don't need to right now. Everybody got this slide? We okay? Okay. This is basically what I just said. Your domain for every single function that you talk about that is quadratic is always going to be negative infinity to positive infinity. If it's a positive parabola, this is the parent function, like if we move up or down or anything, but positive is going to be, your range will always be from the y part of the vertex, and it'll include it, to infinity. If it's negative, it's going to be negative infinity to the y part of the vertex. Your intercepts are going to be where the graph crosses the x and y axis, and we can talk about how to find those in just a second. It's an even function. Your increase and decrease is going to be, it's going to mirror itself. It's going to increase on one side, decrease on the other, just depending on which direction it opens and stuff like that. So, again, this is all stuff that we've talked about. You can find which way the parabola opens by looking at the a term. If it's positive, it opens up. If it's negative, it opens downward. Your axis of symmetry is that vertical line that cuts the parabola in half. If you have a positive parabola, your vertex will be the lowest point. If you have a negative parabola, your vertex will be the highest point. Everyone see that? Alrighty. Sure. If you have a positive parabola that's opening upwards, your vertex will always be the lowest point on that parabola. If you have a negative parabola that's opening downwards, the vertex will be the highest point. I always say, Zoe, when you're doing stuff like this, the easiest thing to do is draw a quick picture. If you see that it's positive, I would go like that. Because then you see, oh, this is the bottom. That's the lowest point. If it's negative, you go, oh, look, there's the highest point. Then you know your range is negative infinity to that point. You know your domain is negative infinity, positive infinity. Kind of just all
Miss Meadows, can you say that again?
together.
Thank you, Miss Meadows.
Sure. All right, let's see if we remember this stuff. In letter A, let's look at A. All right, I have my normal parabola. If I was to graph it, again, this is perfect. Goes through the origin. My vertex is at 0, 0. Letter A, there are some shifts and some stuff going on. What is happening to my parabola in letter A? What does that negative sign out in front mean?
It's going down.
Yep, it's going down. That's a reflection over x. And does anybody know what this +1 at the back means?
The slope goes up.
Moving
Well,
up
I'm sorry. The y-intercept.
The y-intercept, yes, it's a vertical shift up 1. So if I were to do a quick little picture, I'm not asking for anything perfect, I would go up 1 and my parabola would be facing downwards. Just a quick little picture, just to give yourself a mental picture. All right, if I look at B, okay, here's my most beautiful parabola ever. There's some other things going on in here. What's happening in B? What does this -3 mean?
Down 3.
Yep, that's our vertical shift, down 3. Anything at the end, plus or minus, is our vertical shifts up and down. What's going on here? If the stuff at the end shifts things up and down, what do you think happens with stuff inside the parentheses?
Left to right.
Left to right. So which way is this parabola going to move?
Right.
What do we think, right or left?
Right.
Left, because isn't it flipped?
It's the opposite of what you think. This is going to go left 2. Remember, inside the parentheses, anything but the X is the opposite of what you think. That says opposite of what you think. So if I was going to graph this, I would say, okay, my parabola is going to shift from the origin. It's going to go left 2 and down 3. And is it positive or negative?
Positive.
Positive, so it's going to go up. So it's going to look something like that. What is this point right here called?
That's
The vertex.
That's the vertex. Can anybody tell me the coordinates of the vertex?
-2, -3.
It's at -2, -3. You can tell that by the way that this is written in vertex form. This is your H, this is the X part of your vertex, this is your K. Again, the H is always the opposite, it's the opposite of what you think. But you can tell me now everything you need to about this parabola. What's the domain for B? For every single parabola you're ever going to see in your life?
Negative infinity.
Infinity and infinity.
Yes, ma'am and sir. Negative infinity, positive infinity. All right. What's the axis of symmetry? What's the AOS at X equals what?
-2.
-2. Is there a maximum or a minimum point here?
Minimum.
Minimum. That's the lowest it's going to go. And it's at Y equals
2, -3. -3.
-3. Remember, the X part of your vertex is your axis of symmetry. The Y part is your maximum and minimum. So let's talk about range. Okay, there's 2 options. It's either going to be negative infinity to the Y part of the vertex, or from the Y part of the vertex to positive infinity. Which way is this parabola going? Is it facing upwards or downwards?
Upwards.
So it starts right here, which is what value?
The Y.
Okay.
So negative.
So -3, and it's going up till
Positive infinity.
positive infinity. Very good.
Or as you say, to infinity and,
And beyond.
But light year.
Yep. My kids finally watched that movie.
The first one?
What's up? Talk to me.
The axis of symmetry, it cuts it in half,
Yes.
or it's where your X value is?
It's the X part of your vertex. It's the X part of your vertex, but it is the vertical line that will cut the parabola in half.
Okay. Thank you.
Of course. And again, if the parabola is drawn to scale. Kay Lovett can draw a parabola much better than Jan Marie Meadows. Because Kay is super artistic, and I obviously am not. But I try, right? That's all that matters. Okay, moving on to the next slide. This is exactly what we just talked about. It's just in math terms. See how this parabola, the original was here, and then we shifted it up 1 and reflected it. This is the same thing that we just talked about. You guys had our original parabola here, but then we moved our parabola left 2, down 3. See, we didn't need that. Look, this is also what we just talked about. Okay, this is also what we just talked about. This is called, look, in some books it's called standard form. It's also called vertex form in other books. We're going to use the term vertex form here, because you can quickly identify the vertex with how this is written. All right, you can also identify all of the shifts and stuff that occur. We just went through that. If there is a negative sign out in front here, that's going to be our reflection over X. That's what's going to make it flip. Does anybody remember what a number outside in front of our function is going to do?
Doesn't it make it wider or
Yep,
more
very
narrow?
good, very good. Vertical stretch or a compression. If it's bigger than 1, it's a stretch. If it's less than 1, or between 0 and 1, it's a compression. What happens here? We already went through this.
It's the
Shift
opposite.
to the right or the left?
Yep, this is our right or left, and it's what, Zoe?
The opposite of what you think.
Opposite of what you think. And then our K at the end is our up and down, right? It's our vertical shifts up and down. So when you're given a function in vertex form, it's super easy to just figure everything out. What I just showed you, the domain, the range, all that stuff. You can identify that here. So if I just gave you, I don't know, f of x equals negative 1/2 x plus 3 squared minus 10. What's the vertex of this parabola that I just gave you?
-10.
Well, I have 2 points. I need the x part and the y part. So my x part would be?
-3.
-3. Good. The opposite of what you think. And then my y part would be?
-10.
-10. All right. What is this telling you that the parabola is going to do? That negative out in front.
That's a compression, right?
Well, no, this is the compression. What is the negative sign?
Oh, it's going downwards.
It's going to reflect over x. And then the 1/2, since it's between 0 and 1, because we always look at the absolute value of that, is going to be a vertical compression. That means it's going to smush it. It's going to be wider. But you can identify.
Miss Meadows?
Yes.
If you have a number in front of the x, did you cover that? Sorry.
That's going to be our horizontal compressions and stuff. We're not going to get into that right now.
Okay.
Mm-hmm. Isabella just asked, I'll just say it real quick. Like if there was a number here, like say this was a 4. All right, that would be your horizontal because it's inside with the x, your horizontal compressions and stretches. Now, anything with the x is the opposite of what you think, right? So if you have the whole number 4 in front of x, you would think it's a stretch. But that would really be a horizontal what?
Compression.
Yep. Yes. We're getting ahead of them, but that's okay. It's a good review. All right. So what kind of a form is this written in right now? Is this in standard form like we're used to seeing, or is this already in vertex form?
Standard form.
This is in standard form. You can tell me a couple things, though, about this parabola. What direction is this parabola opening?
Up.
It's opening up. How do you know that?
Because it's positive.
Because
positive
the A term is positive. Good. Now, if I were you, I would, first thing I look at, because you're going to have times when you have to match the graph with the equation, I would draw this little picture. I know it seems silly, but it's giving you a mental view in your mind. You can say, oh, okay, then right away I know that there's a minimum. It's not a maximum. Right away I know that my range is going to be from the y part of the vertex all the way up to infinity because of the way that it's going. But if I have to identify the vertex and it's written already in standard form, I have to figure out what that vertex is. And you guys all know how to do this. Let me remind you. Does anybody remember this lovely little formula? If you were in Algebra 2 Honors, you better be saying, yes, of course.
Unfortunately.
Okay, good. Good. Well, at least you do. What is my A term? What would I use for A?
2.
2. What is my B term?
8.
What is my C term?
7.
Yep.
7.
Okay, you guys all know that. So in order to identify the vertex, you got to find the x part first. It's our negative b over 2a. So I would simply say negative 8 over 2 times 2. Does anybody have any questions on where I got those numbers from? Anybody? Okay, here's the issue, guys. Negative 8 divided by 4, I get negative 2. Do you know how easy it is to forget that negative? Or you write it down on negative 8, but then when you go to negative 8 divided by 4, you just put 2. Guys, if you miss a sign, this early in the problem, the rest of the problem will be wrong. Your vertex will be wrong. Then your max and mins will be wrong. Then your range will be wrong. So it is so important that you guys pay attention to signs here, because once you miss a sign here at the beginning, I cannot give you partial credit throughout the rest of the problem. So if I'm identifying the vertex, and I know that the x part of my vertex is at -2, that also is my axis of symmetry, how would I find the y part of my vertex? What's f of x a fancy way of saying?
Y.
So I would say y equals, well, what did I just find out that the x value was?
-2.
-2. So I would say 2, and instead of x, I put -2 squared plus 8 times -2 plus 7. You use negative b over 2a to find the x. Then you take that number and you plug it back in here to find y. And now we just simplify, guys. -2 squared is 4, and 4 times 2 is 8. 8 times -2 is -16 plus 7. Well, 8 minus 16 is -8 plus 7. So what does y equal?
-1.
-1. So my vertex is at -2, -1. Now you guys can tell me a million things. My axis of symmetry is at x equals what?
-2.
-2. My minimum value, since my parabola is going up, my minimum value is at y equals what?
-1.
-1. Good. My domain of every single parabola that we're ever going to talk about is?
-infinity.
2.
-1.
Positive.
Oh, yeah.
Infinity.
That's right.
Always. My range. Okay, my range is going to start right here at the y part of the vertex, which is -1, and it's going up to
Positive infinity.
You can tell all that just by finding the vertex. And now if I threw an extra thing in here and I said, all right, we'll find the X and Y intercepts. You guys are like, oh my gosh, we're doing so much. Guys, how do you find X and Y intercepts?
Plug in 0.
Plug in 0. Let me show you the easiest intercept in the world for you guys to find every time. If I want to find the y-intercept, that means I plug in 0 for x. What is the y-intercept in this equation when I plug in 0 for x?
7.
7. Your y-intercept would be at 0, 7. Now to find our x-intercepts. We've done this. You guys did this on your last test. Finding the zeros, finding the x-intercepts, finding the solutions, finding the roots. It all means the same thing. You would set this equal to 0. And we're only doing a bit of this, and then I'll stop. And then we factor. A is not 1, so 2 times 7. I need factors, guys, of 14. That multiply to give me 14, but add to give me 8. 1 and 14, 2 and 7. Is this going to factor nice and pretty?
No.
No, so that means I would have to use everyone's favorite, super easy quadratic formula. We're not doing that today. Possibly in the next couple days, but not today. But when you're finding intercepts, okay, so the constant is always your y-intercept. Your x-intercepts, you factor. You set the equation equal to 0, and you factor. Hopefully this is coming back to some of us. Hopefully. All right, let's scoot on down. We've already talked about this. This is fun. We've already talked about this. And we already talked about this. Minimum and maximums. I just gave it to you in normal people terms. All right, last thing I want to talk about, and then we're done.
Wait, excuse Miss Meadows?
Yes.
My computer keeps glitching, so I'm gonna log in through my phone.
No problem.
All right, give me a second.
Yeah, I'll see you come in. Okay, hang on. Okay, guys, so you might be asked to write the equation in vertex and standard form given a point in the vertex. So what we're going to do here is we're going to talk about how this is the H part of my vertex. This is my K, this is my X, and this is my Y. So if you guys were going to write the equation of a line, you would write y equals mx plus b. You'd plug in stuff for x and y for the m, and you would solve for b. Then you'd plug in and say, okay, now I can write the equation of my line. We're going to do the same thing. We're going to use our vertex form. They've given us the y, the x, the h, and the k. We're going to first solve for a. So when I do that, I would say 7 equals, we don't know what a is. The x value they gave me is -4. The h part of my vertex is 2. And the k part of my vertex is -2. So I would simply go through here and just simplify. -4 and -2 is -6. -6 squared gives me 36 minus 2. So I'd rewrite this as 7 equals 36a minus 2. I'm going to add 2 to both sides. So I have 36a equals 9. Divide both sides by 36. And I get a equals 1/4. So now that I have my a and I have my vertex, I can write my parabola in vertex form. So I have y equals, instead of a, I'm going to put 1/4. And I have x minus 2 squared minus 2. And then if you were going to go from vertex form to standard form, it's just simple algebra. You would say 1/4 x minus 2 times x minus 2 minus 2. You'd FOIL these first, then distribute the 1/4, and then subtract the 2, and you'd be back in standard form. So just a little direction on how to do that.